This is R.D. Sharma solution class 12th. We are taking chapter 19 VSAQ of the chapter Indefinite Integrals. 1 plus log x whole square divided by x. Now we can get this 1 by x from 1 plus log x. That means if you take t equals to 1 plus log x and we differentiate it dt by dx, 1 will be 0. Log x will give you 1 by x. Now dx can be brought on the right. So we got dt equals to dx by x. So this whole dx by x we have got after this replacement as dt. So this integration will change something like this. We have dt and 1 plus log x whole square. This is 1 plus log x, which is t, so t square. So when you integrate it, it will be t cube by 3 plus a constant of integration. And then we have to replace, because what we have assumed t needs to be replaced here, 1 plus log x raised power 3 divided by 3 plus a constant of integration. So this is how we are going to solve it. The only thing is 1 plus log x can give you 1 by x. Sec square 7 minus 4x. Don't worry about 7 minus 4x. Sec square x dx can give you directly tan x. So you don't need any assumption or any change. It's a direct result. So this is tan 7 minus 4x plus a constant of integration. But after that you have to differentiate this 7 minus 4x, and the differentiation of 7 minus 4x will give us negative 4. So let's differentiate this. This will be negative 4 only left, and that needs to be divided. So we divide this negative 4 and that's the final result. Only one step answer. So this is how, because integration of sec square x is directly tan x. This is from where we derive it. Now log x by x, integration of log x by x. Log x, take t, dx by x, directly you will get. So dt, t, you just have to integrate this, t square by 2, t was taken as log x, so log x whole square by 2 plus a constant of integration. Now this is also a direct formula, that is if you integrate a raised x, this will give you a raised x divided by ln a plus a constant of integration. Now what is a here? It is 2. So in this just replace a by 2. So 2 raised x ln 2 plus a constant of integration. That's your final result. Now this is a direct result as I just suggested. This is how you're going to do it. 1 minus sin x cos square x. See, there are two ways to do it. Cos square x can be written as 1 minus sin square x. 1 minus sin square x can be written as 1 minus x, 1 minus sin x, 1 plus sin x. 1 minus x, 1 minus sin x gets cancelled, but still you are left with 1 plus sin x in the denominator. So that's an issue. So better is to divide this, which I am doing right now. So 1 by cos square x minus sin by cos square x. 1 by cos square x is sec square x, and this sin by cos square x, as I just showed you on the right, it will be tan x and sec x. Now when you come down to this part, the two parts which you see on the left and right, they both are the direct result. Sec square x will give you tan x, sec x tan x will give you sec x plus a constant of integration. This is a direct formula. Okay, so this is the result in front of you, rather than doing the way I was telling you, because it will land you in nowhere. So this is how you're going to go about it. Again, the same approach will be followed here. X cube divided by x square minus 1 by x square. That is, I'm dividing the numerator into two parts along with the denominator in both the parts. So x cube by x square and 1 by x square we are integrating. X cube by x square will be x dx. 1 by x square you can do it separately. It's just x raised minus 2. So in both the cases you have to apply the integration of x to the power n. So x to the power n plus 1 divided by n plus 1 will be the result. So x to the power minus 2 plus 1 by minus 2 plus 1. So x raised minus 1 divided by minus 1. So you'll get minus 1 by x here. So you can just add this. Minus minus will be plus, plus 1 by x will be there, plus a constant of integration. So this is your integration direct result. Alright, from here we started. So this is how you can do it. As I told you, it's a direct result, so you don't have to worry about it. Just separate them out in two parts. Here it's an observational question. If you observe very closely, x minus 1 can be achieved from the numerator, because this x cube minus x square, if you take this x minus 1 common. So when you take x square common from the first two terms, x minus 1 will come. The x minus 1 remains untouched. Now divide both the parts with x minus 1. So you have x minus 1 in the denominator. Now this cancel this out. You get x square here, plus you cancel these out, x square, and then you have x square and plus. See, it's plus. So I'll just change the sign. So this is x cube by 3. So this is a plus. I have changed it to plus now. This will be plus. Integration of dx will be x only plus a constant of integration. So the formal way you need to know how to do this. This is the way you are going to do it. Alright. The reference is important. Now tan inverse gives you direct result as 1 by 1 plus x square. And this is e raise tan inverse x. So it is e to the power. So let me write it in a formal way. E raised tan inverse x divided by 1 plus x square integration we are doing with respect to dx. So when you take t equals to tan inverse x, and when you differentiate this, dt by dx will be equal to 1 by 1 plus x square. Dx goes on the right, so dt will be dx divided by 1 plus x square. Now this dx by 1 plus x square can be replaced by dt, and e raised tan inverse can be replaced by e raised t, because tan inverse was taken as t earlier. So this is now a simple integration of e raised t dt. E raised t will always be e raised t. So e raised t plus constant of integration. Now t was taken as tan inverse x. So e raised tan inverse x plus a constant of integration is your final result. So this is the way you are going to write it. All these questions which we are doing are direct results. I mean, you know that differentiation we can give you the other part of integral, and it makes your life and question easier. So in this case, whenever you encounter an under root, this under root needs to be eliminated first. So we have trigonometry for that. We can just write x as say cos theta or x as sin theta or cos theta, any of it. So x equals to sin theta, when you put 1 minus x square will be 1 minus sin square theta. So 1 minus x square, 1 minus sin square theta here, and this will give you what? Cos square theta. And since we have an under root, actually plus minus cos theta will come, but let it be like this only. So integration of 1 by cos theta will come. Cos theta goes up, it will give you sec theta. So you can integrate sec theta. So this is not what we expect, because we have to differentiate also. X was sin theta. So we need to differentiate because we need to get rid of dx also if we are replacing it by some theta term. So dx becomes cos theta d theta. So now when you have cos theta, you don't have to worry about the denominator, because denominator we got cos theta already. Numerator also cos theta d theta. Now you can cancel this cos theta, only you have to integrate d theta. So theta will come, theta plus constant of integration. But theta was initially was x. If x is sin theta, theta will be sin inverse x. So theta becomes sin inverse x, and then you can write this. So write this sin inverse x here. So let's write it, sin inverse x plus a constant of integration. That's your final result. So this is how you're going to go about it. Use trigonometry. If you want to put x as cos theta, that also you can do, right? But there may be some other interjections. Now this is quite straightforward. Just multiply sec x inside. You'll get sec square x, you'll get sec x tan x, and you have directly the integration of these two terms. So I'm multiplying sec with sec x tan x. So the first will give you sec square x. The second will give you sec x tan x. Then you integrate these two. Sec square x will be tan x, and sec x tan x will be sec x only plus a constant of integration. This is your integration. So we need to solve it exactly like what I am presenting here. Now we have direct formulas like x square plus 16. When you have 4, 9, 16, 36, all these are squares. 2 square, 3 square, 4 square, 5 square. So you can use the formula directly. 1 by x square. 16 can be written as 4 square. So 1 by x square plus 4 square. Now this formula, we have 1 by x square plus a square. And you know that it is simply 1 by a tan inverse x by a. So 1 by a tan inverse x by a. In this question, a we will take it as 4, not 2. I'll just change that one. So this will be 1 by a, that is 1 by 4. 1 by 4 tan inverse x by 4 plus constant of integration. So this is the formula you are going to use. So again, a very straightforward question for you. Now don't worry about the under root. It just like x. X to the power 1 is x. X to the power half is under root x. So now multiply this inside. Root x into 1 will be root x. Root x into x will be x into root x. So that root x is simply x to the power half. You have x raised half dx. X under root x. So x to the power half. This is x raised 1. And 1 plus half is 3 by 2. So x to the power 3 by 2 will come. 1 plus half is 3 by 2. This is x raised 3 by 2 dx. Now let's integrate x raised. N is x raised n plus 1 divided by n plus 1 plus a constant of integration. This will give you x to the power half plus 1 divided by half plus 1 minus x to the power 3 by 2 plus 1 divided by 3 by 2 plus 1. Half plus 1 is 3 by 2. 3 by 2 plus 1 is 5 by 2. So x raised 3 by 2 divided by half plus 1 is 3 by 2. So let's write this 3 by 2 in the denominator. This 3 by 2 plus 1 will be 5 by 2. When it goes up, it will be 2 by 3. When this goes up 5 by 2, it will be 2 by 5. And you know that x to the power 5 by 2 is already there. This goes up, 2 by 5 will be formed, and that will be plus constant of integration. This is your integration, final result. Now this is how you are going to do this. This is a simple classic example of integration of x to the power n. Just multiply inside and use this formula, and this is how you are going to write. At first glance, this question seems to be complicated, but it's not. Why? Just take the denominator, and when you take the denominator and differentiate it, are you going to get something related to the numerator? Let's see. We have 3x square plus sine cx 6x, which we have taken as t. Now let's differentiate it. dt by dx will be what? It will be 3 into 2 into x. So we are getting something here. 6x here. Then sine 6x will be cos 6x, and differentiation of 6x will be 6. So 6x plus 6 cos x, let's take 6 common. When you take 6 common, x plus cos 6x will come. Let's take 6 in the denominator. So what you see in the right is actually the numerator which we wanted. So x plus cos 6x dx is the numerator. So you can just write dt by 6 in this case. 1 by 6 can be brought in front of the integration sign. The denominator is a t. dt by t is log t. 1 by 6 is the precursor, or you can say the coefficient. So integration will be 1 by 6, and then 1 by 6 log modulus of what was t? 3x square plus sine 6x plus constant of integration. That's your final result. So this is how you can do it, and the best way to write is in this way. When you take 3x square plus sine 6x as t, all will be easier for you. Now this question and the next question are almost similar, and it is based on the formula which we have already proven. So integration of x minus 1 by x square into e raised x dx is fx e raised x plus constant. Write the value of fx. Now let's integrate this. X by x square, let's separate them out. X minus 1 by x square, it can be written as x by x square first, then minus 1 by x square. X by x square is 1 by x. This is minus 1 by x square. We have done a question like this in this exercise only. So e raised x is already there. 1 by x minus 1 by x square is just a form of writing x minus 1 divided by x square. Now you see that e raised x is already there. And fx, if you consider to be 1 by x, are you getting f dash x as the second term? Yes. F dash x is a negative 1 by x square. So this integration can be written as e raised x fx, which is this one, and then f dash x. So just add it, and f dash x will come, and this is equal to fx e raised x. So the direct result of this integration is what? Fx into e raised x. What is fx here? Fx is 1 by x. That's what we have started with. Fx is 1 by x. So just write 1 by x, and this is equal to fx e raised x plus c. Now equate these two. So when we equate, 1 by x is actually the fx. The function is 1 by x, which you can write like this. This is your final result. So as you see here, the directions I gave you is exactly like this, but the English-like thing and the explanation should be like this. This question is no different from the previous one, because already you know that this question has been done in the previous few questions. So just multiply this sec x inside with 1 plus 10x. So first we'll write this sec x, and then we'll write sec x 10x, which eventually will come when we multiply 1 plus 10x with sec x. Now in this is the exact result of a standard. This standard is e raised x fx plus f dash x. So the direct result of this integration is fx e raised x plus a constant of integration. Now when we equate this, what was taken as fx? Sec x. Because if you take fx as sec x, then you differentiate it, that is f dash x, it should come as f sec x 10x. So f dash x sec x is sec x 10x, which we already know. So that's why e raised x fx is the result which will come, but the question is asking only about fx. So the fx is simply sec x. The answer of this question is fx equals to sec x. So again, the same approach which we have used in the previous question, which is the 56th question. Now integration of 2 by 1 minus cos 2x. 1 minus cos 2x can be directly changed into, because we know the formula, it will be 2 sine square x. 1 plus cos 2x is 2 cos square x. So when we write 2 sin square x here, 2 gets cancelled, sin square x goes up. This will be cosec square x. And cosec square x dx has a direct result, which is minus cot x. So no assumption, nothing, just minus cot x plus constant of integration. This is your integration. Now the reference, if you see here, it's 1 minus cos 2x will give you 2 sin square x. Cosec square x minus cot x. Now write the antiderivative of 3 root x plus 1 by root x. See, this question is quite easy for you, but the question is asking antiderivative. Sometimes people may get carried away or try to understand what is this antiderivative. Antiderivative is nothing but integration. Anti-integration is derivation. Like you can understand like that. So this is, let's separate them out. So integration of 3 root x will do separately, and we'll separate out this 1 by root x also. So we have plus 1 by root x integration dx. So 3 root x is 1, x to the power half is simply x to the power half plus 1 divided by half plus 1. So we get x to the power 3 by 2 divided by 3 by 2, it goes up 2 by 3, 3 get cancelled. So the first term will be only 2 into x to the power 3 by 2. Now the second term 1 by root x, let's do it. So I've written 1 by 2 root x, it's wrong. Let me do it again. So x raised minus half, x raised minus half plus 1 divided by minus half plus 1. So this will be x to the power half, and this is half, 2 goes up. So 1 by root x, the result is twice of root x. So this just write 2 root x here. And again, a plus constant of integration, which is very important. So let's write the formal answer. It will be 2. You can take 2 common. X to the power 3 by 2 plus x to the power half plus a constant of integration. Now if you want to understand how this can be written, this is the reference solution for you. You can follow this. Now we have cos inverse sin x. So we just need to cancel this inverse, and sin can be converted into cos term, which we already know. Sin 90 minus theta is cos theta, cos 90 minus theta is sin theta, we already know that. So this is sin theta, it will be cos 90 minus theta. Similarly, if you do sin 90 minus theta, it will be cos theta. So this 90 can be written as pi by 2 in radians. 90 degree is equal to pi by 2 radians. So cos inverse in place of sin x, I'm writing cos pi by 2 minus theta. So cos inverse goes, pi by 2 remains with a theta. Now what you can do is you can just separate these two term out. Pi by 2 separate and x separate. It's not theta actually, it's x. I just showed you theta for a reference. So pi by 2 goes out, integration of dx, then we have x dx. So pi by 2 dx is x only, and this will be x square by 2 plus constant of integration. This is your I. Now you need to know how to write this, because all those things which I say, it needs to be penned down also, and this is how you are going to write it cleanly. 1 by sin square x cos square x. Now sin square x cos square x is simply sin x cos x whole square. Now you can have a 4 in front of this in numerator and denominator. With that, the purpose we are going to solve is, if you have 4 numerator denominator, this 4 can be taken inside. It will be 2 sin x cos x whole square. So we have 2 sin x cos x whole square, and this 4, actually this 4 is 2 with a square. So 2 sin x cos x is sin 2x. So we have 4 divided by sin 2x whole square. And when it goes upstairs, see, sin 2x is cosec 2x, and sin square 2x will be cosec square 2x. And you know that cosec squared theta has a direct integration. 4 comes out, cosec square x 2x dx, whatever is inside doesn't matter to us, because we are more interested in minus cot 2x, which will come. 4 is already there, and then we have 2x. This also needs to be differentiated, and it has to be kept in the denominator. So this gets cancelled, 2, so minus 2 cot 2x will come. Let me write the final answer here. Minus cot 2x and then a 2 in front. So minus 2 cot 2x plus constant of integration is your final result, which gives you an I. Okay. Now this sin cos just have to be changed into this sin 2x, and then rest will be easier. So this is how you're going to write it with all the formulas, etc. Now this question is quite evidently solved previously. 1 plus log x will give you 1 by x. You already know that. So just take t equals to 1 plus log x. Differentiate it, dt by dx will give you 1 by x, that is dx by this dx can be brought in the right. So dt gives you dx by x. Now dx by x is already in the question. It's not dx by x dx, sorry for that. It's just dx by x. So dx by x can be written as just dt. 1 plus log x was taken as t. So dt by t, which is log t in the modulus plus constant of integration. Log in place of t, replace it by 1 plus log x. Write 1 plus log x plus a constant of integration. It's your final result. Okay, this is how you are going to go about it. I think we are quite clear about these kind of questions now. So this is all about this exercise. Thank you so much. Have a good one.